Alright, hello, my name is Evan and welcome to my global rain tutorial. We're going to be using a material function to make this effect global across all the materials, and the main thing that's important is that, for example, I have my asphalt material here. If I go to the asphalt, it is a material instance, and the base material has our material function in it. And to get your material looking like this, you have to make sure that you click use material attributes. It will get rid of the shader that looks like this part, and it will just make it all combined into a material attributes. This makes it nice because we can take the previous attributes, do a make material attributes, just drag everything into that one, and now we have a material attributes, and the function is so easy. We just plug it in and plug it out, and now you have global rain on all of your materials that derive from this main material. Now, if you don't know how to make a material function, just search function, material function, and you will get a graph that looks like a shader graph. And the main thing to do right away is to expose to library. Check expose to library, yes. That way you can actually search it like this, and MF noise rain will come up just like that, and you can put it into whatever you want. So let's just first look at this effect. It's a pretty big graph, but the way that I've made it is so that you can take things in and out as you want and based on the needs of your project. Like right now it is slightly intensive. If we go into shader complexity, you can see that it's not horrible, but it's slightly more intense than without the effect, which it would be green. And for most projects it'll be fine, but if you need to severely optimize this effect, just know that you can go in here and you can take many of the layers out, which I will be getting into. Alright, so real quick, I'll go over all these parameters that we have in the parameter collection and how they affect the global rain system. So overall wetness, just a basic shine that's put onto everything. I think when it's max rainy and you have puddles, I think only like 0.6 is needed. Rain intensity is how intense this effect is with the drops and the streaks going down the objects. Can turn that down to 0 and there will be nothing. Put it up to 1. You can turn it up more if you want more rain. Rain darken is how the raindrops and streaks darken the color that's below them. Value like 0.1 to 0 is fine, but most of the time I found it was actually kind of good at 0. 1 is obviously too much, but it's good for like debugging the mask. Puddle darken is at 0.9. So this is how dark the color below puddles gets when the puddle's at max depth. So if you put this up to 1, you won't see anything under the puddle. I like stuff like 0.9, 0.95. You can still see a little bit, but when it's deep, you can't really see the bottom, just like it'd be in real life. Rain normal. Pretty simple. This is how strong the normal is for these raindrops. And so if we put this to 0, it's just really affecting the roughness and the rain is not really sticking out. And turning this up really makes the rain just more visible and affects the reflections in normal. Puddle amount, how much puddles we got everywhere. This can go anywhere from like 0 to until it's full, but helps you dry out puddles, and this can be animated smoothly to be a cool like rain collection effect. Puddle contrast is the contrast of this puddle mask. Pretty self-explanatory. Turn it down, less contrast, turned up, more contrast. Keep it at 2 for now. Puddle scale, scales the puddle system. And we have 2 textures, and you'll see why the other one doesn't get scaled later. And wind X and Y. So on the puddles, we have wind ripples that you can see if we look into here. There you go. You see those wind ripples? Over there, we can turn up wind X and wind Y to make them faster or go the other direction. And so you just have a light wind effect that adds to the overall like shape of these puddles. Just a small detail. And wind X and wind Y are just separate X and Y values for the wind. So now let's get into this effect. It's pretty complex right now, but as I said, it's modular. You can take things out as you want. So at the beginning, we have the blending, simple as getting our material attributes. Then we turn them into named reroutes for color, specular, roughness, and normal. And then we also will make named reroutes for color out, spec out, rough out, and normal out. But when you make a named reroute, let's say we do opacity out or something. If you're putting it into the set material attributes and you just made a named reroute, this is not the correct one to plug into here. As you can see, the ones that we get, they have 2 values, or 2 pins, one on each side, and the ones that you want to put are already set, so we're setting it to the final values. You're going to want it to only have one. So the first one that you create is going to be the set named reroute, so you plug in what you want that value to be, and now if I look up opacity out in named reroutes, this will be the correct one to plug into the out, because it only has 1 pin on the right side. So simple blend chain here, we just get things and then we put their outputs right there. Output, out material, simple as that. This is our rain mask right here. And so we have rain panning for the UVs, simple as we have a side speed, so how fast they're gonna go, multiplied by time, multiplied by this arbitrary speed value, and then we mask that to get UV. But for this, we are not using textures necessarily. We do use one texture down here, I'll show you later. But for most of it, I like doing things procedural so you can save texture space, and it just gives you more control over the detail and scale of your textures that you are just generating on the fly with this noise node. And because we're doing the fast gradient 3D texture, which is the cheapest one, and it's also good because it's a 3D texture, so we can sample it in all 3 axes. We're going to need not just a UV, but we're also going to need the UVX, I don't know, the third value, which is basically turns into XYZ to become world position in here. So to get that, we took in our panner, the coordinates that we put in is the XY of absolute world position. And the reason why we're just putting XY up there and not XYZ is because we want the Z to be completely separate. So the rain mask, we're evolving over time with these 2 values, and then we're pulling it down, having the gravity effect with the Z, which we want to be different from the side speed. So we have down speed and side speed. Down speed is going to be a lot faster, and that's what creates this effect of it going down like that. And the reason why it looks like splashes on the top is we're just panning down through a noise texture. So this is just noise getting evolved over time really quickly, which in turn looks like splashes, which is super nice. Getting back in here, so to make the Z value go down, of course, we subtract multiplied by time, multiplied by our speed, and then we can divide the scale. So what rain Z scale does is, on the top, our noise scale has not been manipulated yet. It's just taking the absolute world position, but we want the Z to stretch out when it's on the side, right? We want it to be stretched out like rain streaks, so we want to just stretch the Z out down here with this rain Z scale variable. So if you can see, if I turn it up, the rain streaks get longer and longer, and if you turn it down, they're really short, and at 1 it's just gonna be the same scale that it is on top right here. And I think between like 6 and 10 is a good value for right now. I like 6, that's why I had it set at, and that's a good and what it basically means is that we're stretching it out 6 times versus the texture that we see on top. So this is the normal noise, and then the stretched out that we see on the side is 6 times as long on the Z-axis. Next up, we're going to make these into a usable vector 3 that we can plug into our noise. So we append the Z to the XY, and then this is an overall dividing scale of the rain that you can change on a per material basis versus using the material parameter collection. So 2 will make it smaller, 10 will make it bigger, simple as that. And I think this one actually has a this one is already overridden, so that's why it's not changing. So yeah, this, as you can see, changes the overall scale of everything, both the top and the side. So we'll keep that at a nice 3 right now, I think. And then finally, we plug it into our procedural noise node. And this is a fast gradient with 2 levels, pretty simple noise, not very expensive. And that's really all we need to create this cool mask that we have. The rest to this mask is we're just multiplying by rain. Which this is a multiplier, again, that can be changed on a per material basis. So for example, for the ground, I changed a lot of the values on the material basis to make these puddles look different, because water is different from a solid. The splashes would be different, the ripples would be different. It's just different parameters than for something like this right here. And so yeah, right here we have a large subtractive mask, which is just a larger procedural noise as before. This one goes over the whole map. It's really big, and it just decides where rain is going to show and where rain is not going to show. And again, using the panner and stuff is constantly evolving so that it's always changing where the rain is going to show. And if we go way up we can kind of see this at a larger scale. If we get in the sun, you can see that there are these outlines of a really simple noise. And that is our huge mask that we're using to basically cover everything and decide, is there rain falling here? Like if we go up close to the puddles, you can't really see it anymore, but what you can see is that sometimes it's rain splashes, sometimes it's wind ripples. And we're using that mask to then lerp between the wind ripples and the rain splashes. And so now that we have our rain looking a bit more natural, just simply we lerp it between 0.2 of itself, so it's not a really sharp edge, so that there's still a little bit of rain even where the mask is. And then we're ready to saturate it and plug it into our rain mask. So this rain mask is really important. We're going to use it in a lot of the rest of everything. But before we combine everything together, the next things we're going to need to do is puddles. So puddles, again, it's procedural noise at a different scale. Yet again, we'd use the puddle scale, absolute world position right here. And then we max it with, this is just a little detail that I added. Again, if you're optimizing, you can just completely get rid of this max and get rid of this texture sample. I just have a puddle mask right here that I added on to everything to add these details in between the big puddles like this. I think it adds a nice amount of detail, but you can get rid of it for optimization. So we max between those two, and then we multiply by our facing up. What is facing up? We just get basically we get a 1 to 0 value for, is this vertex facing straight up, because we don't want puddles on the sides of things, right? Puddles accumulate where it's flat. So we only have puddles, we multiply it by the facing up mask, and then we only have puddles where it's completely flat. We multiply by our puddle amount, by our puddle contrast, we power it, saturate, and now we have our puddle mask. So then the last mask that we're doing is we need to make our wind ripples. This is just a simple tiling noise, not very obvious, just adds a little detail, a little bit of good normal detail to these puddles. And again, we're just taking world position, dividing it, panning it, using these wind values this time, plug it into, this is a simple low res tiling noise. I think it's like 64 by 64 or something. And then we are multiplying it by our puddle mask. The wind ripples are not anywhere where the puddles are not. And then we're doing a similar thing here with the subtract mask, where we have I can get rid of this right here, where we have a multiplied by 0.3 version and the full version, and then we lerp between them using the subtract mask. This time we're using the reverse of the subtract mask, so that where there's wind ripples, there will not be rain splashes, and where there's rain splashes, there will not be ripples. Now we have our wind ripples output, and our mask, our puddles, and our wind ripples output, these are all just from 0 to 1, right? We just have a black and white mask right now, and that's what's shown like this. And down to the detail, these are also right now just a black and white mask. So far we haven't made the normals, which we are going to do up here. So to make fake normals with a black and white mask, first, we multiply by our rain normal amount, then we're going to add in the wind ripples, and then what you do is you take whatever your black and white mask is, and you ddx, multiply by -1, then you take the same thing, ddy, plug it into a make float 3, have this value be 0. Now you've made a fake normal map in view space. So then we transform from view space to tangent space, mask that out, so we have an xy, then we append 1, so normal strength is 1. And then we have a fake normal map right there. If we take our fake normals and plug them into color, it can show you what we've created. So let's do this. As you can see, we've made a normal map for everything, basically. And it's super cool. You can make normals with black and white. You just need to use that ddx and ddy function. There's also perturb normal, HQ, and prepare perturb normal, but these are more expensive, and also you cannot use them in UEFN. So because I work in UEFN sometimes, I use the ddx and ddy method. So with our fake normals now, we need to, now we can apply, so we get rid of this normal view. If we don't flatten where the puddles are, it's going to keep the normal of the material below. So we need to take our puddle mask and flatten our in normals wherever the puddles are. This makes the completely flat effect, looks good. Then we're going to need to add in our fake normals, which includes all these splashes and everything, all the wind ripples. And now we have an out normal that combines our original normal of the material that you're using and then our rain on top of it. So it adds a lot of depth and makes things look awesome. But we're still not completely done yet. 2 simple things left. So we've done our normal out. We just got our normal out over here, but we still need to do color, specular, and roughness. So to get the color, we're just taking color in, and then we take our new rain mask and we're darkening it at the rain darken amount. And then we are also darkening puddles with the puddle darken amount right here. Put it into a subtract, then put it into a lerp, saturate. Now we have our new color, which we plug in out there. For roughness and specular, you want where the water is to have a low roughness amount and a high specular amount. So for rough in, we put it between 0 and whatever we had before. And the lerp alpha is our rain mask combined with puddles. And then we clamp it to overall wetness, and that is just adds the clamping the max to overall wetness makes sure that it's always at least as wet as overall wetness should be. Then for specular, we simply go between specular whatever we had before and 1, which should be the shiniest, and we're using our water mask. So wherever the water is should be super shiny, and wherever the water isn't, we can just use the original specular value. Alright, so after that, you have a modular procedural global rain effect that you can plug into whatever material you want, just using this material function. So thank you for watching. Leave any suggestions or comments, critiques below, and have a good rest of your day. Thank you.